Hello, everyone. Hi. How are we doing? You know, you all look actually pretty awake, which I don't know, I'm pretty jet lagged, so I'm surprised that you guys are so awake. Today I'm going to talk about WebAssembly, and many of you may not have even heard of that. You're just like, what is WebAssembly? So I'm going to answer some of those things, but first I just want to make a little statement, and that's, I really feel that we're on the brink of a revolution, and it's early. Right? It's very early in the revolution, but I feel like WebAssembly is going to completely change how we think of web apps and what a web app is capable of doing. Completely change it. Now, it may be a couple years out, but we're on the brink. So as Gerard said, my name is Jay Phelps, and I'm an engineer over at Netflix. And the WebAssembly is important to me because I'm a big compiler nut, so I like to work on compilers in my free time. And when I first learned about WebAssembly, I tried to get involved as much as I can. Obviously, I still have my full-time job, but I wanted to express some of my excitement and passion to the rest of the community, because I noticed that a large number of people, whenever I talk to someone about WebAssembly, they'd say, I've heard of it like on Twitter or something like that, but I really don't know what it is. And people are always usually excited. So what is WebAssembly? Well, for one, it's also known as wasm, which is an abbreviation. WebAssembly, ASM is usually the abbreviation for assembly. And it's an efficient, low-level bytecode for the web. And that's a cool catchphrase, but what does it really mean? What does it mean when I say efficient? When I say efficient, I mean that it's fast to load and execute. And when I say load, I mean it's fast to transport the compiled files over the internet to the person's browser, and then it's also fast to parse those compiled files, because they run inside a virtual machine. And once it's done parsing it, it is still fast to execute. And it's efficient and fast primarily because it is a low-level bytecode. And if you're not familiar with the term bytecode, this is an example of one of the WebAssembly operators, instructions, I guess is a more familiar term for it. And this is a hexadecimal, so this is 1 byte. So because us human beings don't usually read binary, at least I know I don't that often. WebAssembly is intended as a compilation target, right? So you will write in some other programming language like C, C++, Rust, and possibly some other ones that I'll talk about. And then you compile that ahead of time to WebAssembly, and then you ship those WebAssembly files to your browser. So here's an example. If you're not familiar with C or C++, I think it's fairly straightforward. Basically you can just ignore the types, the int stuff, and it's pretty much exactly like JavaScript. This is for generating a factorial. And with WebAssembly, that C code equals basically this binary code, this byte code, right? And we're going to come back to this, so don't worry if this is a little like, oh, what's going on? WebAssembly is also designed to be safe and portable. And safe and portable, what I mean by that is it's in the same way as JavaScript is, right? You don't have to deal with memory overflow exploits and things like that, and it's portable. So it'll run in any browser that supports WebAssembly, just like JavaScript runs in all of these browsers, because it kind of is the same goal of what Java intended to do. And Java's been really successful at this on the server side, but not nearly as much on the web side with like the Java applet stuff. So there's a really great quote from Ben Smith, who's on the Chrome team, and he said that WebAssembly is the shortcut to your JavaScript's optimizer. And it's actually very true. It's not a metaphor. In all the browsers that have implemented WebAssembly, they literally use the existing virtual machine they have, because it's been hardened over the years, and it's very fast and very powerful. But because WebAssembly is a strictly typed bytecode, it can go straight to the optimizer and doesn't need to do all these intermediary just-in-time compilations. So you might be thinking, is this going to kill JavaScript then, right? If this is a shortcut to that optimizer, why would I use JavaScript then? I can get faster performance to that. And if you ask the core team of Chrome or Mozilla or any of those, and they're going to tell you, nope, this is not intended to kill JavaScript. And they're right. That's not the intent, and it probably won't kill JavaScript, but I am going to make a little prediction, and I'm going to say, well, maybe someday it might not entirely kill JavaScript, but it's going to change the way we write our web apps enough that you may end up writing majority of your app in a totally different language, maybe even a language, this is a bet, that doesn't even exist today. So the other question you might ask is, well, then will we be compiling our JavaScript to WebAssembly, right? If we can shortcut to that optimizer, why wouldn't we just compile it? Well, that's not really feasible because JavaScript is extremely dynamic. Extremely dynamic. And sometimes we forget because we try and use best practices to not use some of those dynamic features, but technically, there are a lot of really, really dynamic things that you can do with JavaScript that are pretty complex. And so to have that compilation, you'd have a fairly large runtime. And in many cases, you'd actually have to ship almost a virtual machine yourself. So we're talking several megabytes of code just to be able to run the code that your application contains. Now, as the WebAssembly gets further and further along and adds additional features, this becomes less of a valid argument. But as of now, in the future, it does not appear that JavaScript is going anywhere. It's a great language for its intent. But WebAssembly just basically opens up new possibilities that weren't really feasible today. So it would almost be slower if you tried to compile JavaScript to WebAssembly. It doesn't make sense. So it's still missing things. The MVP, or the V1 of WebAssembly, is best suited and was kind of designed around the C++ or Rust use case. And why is that? Well, since WebAssembly is very low level, it's a very low level language, it makes sense that programming languages that are basically just one step above an assembly language would be easier to compile to that, right? So languages like C++ and Rust, they don't have garbage collection. They use different techniques. Like in C, you might use normal malloc, just manual memory management in C++. If you're using the new versions, you might use smart pointers or auto and things like that. In Rust, they use a totally different paradigm. That's a really great talk in its own, actually. But these languages don't use garbage collection, so they don't need all this complicated runtime stuff to keep track of that stuff. So WebAssembly is a really natural target for them. And on top of that, these languages aren't really 100% designed or intended to have to call into complex JavaScript things, like mutating the DOM. Like, it doesn't really make a whole lot of sense to build your entire HTML app in C++, because C++ was not designed around that use case. Certainly you can do it, but more often than not, when people are writing these C++ or Rust things, they're usually going to target things like WebGL. Or they're going to be more library specific. Like, imagine in the future being able to write your own JSON parse utility that was able to parse 64-bit integers. Like, those type of things are really great use cases for these low-level systems languages. But other languages, I think, I'm really confident, I don't just think, I'm very confident that other languages will be very popular in WebAssembly very soon. And one example of that is TurboScript. And I don't know if TurboScript is going to be popular, but I think that it really shows that you can have your cake in a lot of ways and eat it too. And let me just show you a little snippet of TurboScript. I can guarantee no one here has probably ever even heard of this, but what does this look like to you? Thank you. Yeah, TypeScript. This looks like TypeScript, right? And if it didn't say float 32, and if you didn't say delete position at the bottom, you might think this was TypeScript, because TurboScript was designed to basically make the TypeScript programmer or the JavaScript programmer write at home. But guess what? This compiles to WebAssembly. Now, before you get too excited, because WebAssembly doesn't have a garbage collector yet, you have to manually manage your memory. So every time you new up an object, it's basically calling malloc if you're familiar with the low-level stuff. If you're not, it's okay. It's creating a new instance of that object when you call new. And then if you have to manually call delete to free up that memory. If you don't call delete, that memory just gets leaked. And and especially if you lose a reference to that, and then you can never delete it, and the memory is just leaked. So But when you're doing things like libraries, like let's say you're making utility functions that do some sort of mathematical computation, being able to managing your own memory is really not actually that big a deal. People are very used to that when you're writing in languages like this. Or in fact, you may not even need to allocate on the heap. You may be able to just use the stack, and that just basically means you don't have to call new. You just create objects that will just automatically be reclaimed when the current function returns. So I think these type of things really show that brand new languages, I think, will be designed specific for the web use case. Like I just heard, and I haven't confirmed this, but I heard it like 2 days ago, someone here in the audience told me this, that Elm, which is a programming language very much based on Haskell, the Elm is designed specifically for the web, and right now it targets JavaScript, but they have recently decided to start looking at the future of compiling to WebAssembly. I don't think they're going to be able to do it anytime super soon because of memory management stuff, but we'll get to that. So when should I target WebAssembly? What kind of use cases is it best for? Well, right now in the V1, they're really trying to focus on these heavily CPU-bound computations, things that deal with math, where you're just using numbers, maybe 32-bit, 64-bit, any kind of numbers, you're doing some sort of computation. WebAssembly really shines with that. And the most common thing you'd think engineers think of when they think of numbers is games. At least if you've ever written a game, there's tons of pixel stuff. And a lot of these are going to be heavily OpenGL. And so you can write your app in C++ or Rust, your game, using the OpenGL bindings that you're very used to, and compile that to WebAssembly, and it will run in a browser. And I want to show you a little quick demo, see if it plays. Oh, please play. Play. Ooh, it's being really slow. Oh no, it's being jittery. Oh well, that's okay. I think you can get the idea that this is an example. This is actually running in Firefox, the latest version of Firefox, without any flags. Didn't have to enable anything. I just went to this website and this runs, and I can move around on my keyboard. And there's a whole bunch of other demos that really show off that even though WebAssembly is brand new, you can already do things. This is running the Unreal Engine, for those of you familiar. So pretty exciting stuff. But most of you probably don't write games. I don't write games. So the game stuff is not super attractive to me as an engineer. But the other use cases are coming sooner than you might think, right? So you'll likely be compiling WebAssembly, or excuse me, consuming WebAssembly binaries very soon. Even if you're not actually writing code that compiles to it, you'll start to see compiled projects and libraries showing up on NPM. So keep a lookout for that, even if you're not interested in WebAssembly today. So let's circle back a little bit. What was that? What's that binary stuff that I showed before? Right, I had that factorial, and then I showed that it got converted to this binary representation. Well, like, what the heck is that? Well, I know, like me, when I first saw binary years ago, like I'm just like, I don't want to look at this. This is actually a hexadecimal of binary, but crazy stuff, right? It can be really intimidating when you start looking at binary, thinking about, oh, do I have to deal with this? Oh, I just don't even want to deal with it. But the pro tip I'm going to give you is don't worry about it. Like there's tooling already today around this where you don't need to really worry about that. You can certainly if you want to. If you nerd out on that, more power to you. And actually hit me up on Twitter because I want to nerd out on that too. But for the most part, unless you're implementing your own compiler, you don't necessarily need to know a whole lot about binary. So there's a textual representation of WebAssembly that's available. So the text is going to be to the rescue. So, and this is what that factorial function looks like in WebAssembly in the textual representation of it. And this is text, right? So you can read text, presumably, but you may not right now understand what this means. You may not understand the actual semantics of that. But let's dive into this a little bit. Let's learn the fundamentals of WebAssembly so we can try and demystify this text when you see this. Because this is the text you're going to see. Like if you ship a WebAssembly module to the browser and you maybe set the debugger up or you pause on exception, that's the textual representation you're going to see. So WebAssembly is a stack machine language. And that's really important to understand if you're going to be actually trying to debug WebAssembly itself. Now, if you never debug WebAssembly for some reason, then you don't need to know that. But if you are debugging WebAssembly, it's important to know that. So you might be asking next, well, what the heck is a stack machine? Like, if I have to know this, what is it, Jay? Well, let's first cover a stack. Many of you may already know what this is, but I really want to make sure you completely understand what a stack is. A stack is a data structure that basically has two operations. You can push things onto the stack, or you can pop things off the stack. Let's take a look at what that might look like with a visual stack. We've got our stack here, and let's say we've got an item. Now what we want to do is we want to take that item and push it onto the stack. So there it goes. Now we get another item. We want to push that onto the stack, and it goes on top. And that's an important distinction. It goes on top. It doesn't go on bottom. It doesn't go in some random order. When you push things onto the stack, it's always on top. So we'll push one more for good measure. And then there was the one more operation. There was the pop. So if I'm popping something off a stack, of course, we're going to take the top thing. We're not going to go randomly. We're not going to go in the bottom. We're going to pop that top thing off the stack. And likewise, when we continue to popping it off, and there we go. Now we've got an empty stack. So this pattern of pushing and popping on a stack is called last in, first out order. So that's important, and I hope that helps fully understand what a stack is. And if we want to apply this to the stack machine, it's a stack in which the items that are on the stack are instructions. So these instructions run and evaluate, and they push and pop values on this stack. And you may already be familiar with one form of stack, like a call stack, for example. And each time you call a function, you're putting that function on the stack. It executes a bunch of things, and then the call stack returns. It pops all of those things off of the stack. So let's look at some WebAssembly. This is not scary, I hope. So let's start very simply. This is not WebAssembly, but this is the very basic 1 plus 2, right? And in almost every language, this is how you do it, unless you're in Haskell. But this is what the WebAssembly example, or excuse me, the WebAssembly for the add operation looks like. This is called a mnemonic. So on the left, we have a textual representation of that. And on the right, we have the actual binary opcode. Now, you don't need to memorize the binary opcode. Again, textual representation, leaning heavily on that. So back to our 1 plus 2, this is what the code looks like to add 1 plus 2. We've got a constant of 1. It's a 32-bit integer. Constant of 2, and we're going to add those two things together. So let's go back to our stack visualization. Constant of 1, that pushes the 1 onto the stack. A constant of 2, we push a 2 onto the stack, and then we're going to push add. We're going to execute add. And what add does is it's kind of like a function call. It's actually an instruction, but you can think of it kind of like a function call that the computer itself will run. And it takes basically 2 arguments. And how it takes those arguments is it's going to take the top 2 items, and it's going to take those off the stack. It's going to add those together, which is 3. And then it'll put that back on the stack and replace those 2 values. So now we have the number 3 on the stack. And so from here, the next instruction might be pushing or might be dropping it off the stack like you don't care about it, like return void, or you may be logging this out or something like that. Here's a great example. Like if you had a log function, this is how you do it. You'd add the 2 numbers together, and then you call the log function. So call is going to receive the result of add, We've got a stack of instructions, right? And this, I think, is fairly easy to understand. And it does take a little bit to get used to the actual output, which you'll see here, which is that the compilers usually apply lots of optimizations. So even though you wrote certain code, the actual output may not be what you expect it to be. And I'm not going to show some really complicated examples because I don't want to. I mean, it's just going to confuse you. So what's the point? But like I can show you like a trivial one, like a really trivial one for this example. I don't know of any compiler any native compiler that's not going to just do this, right? Like it knows statically at compile time that 1 + 2 = 3. So it's just going to convert that to 3. And most compilers are going to be even more clever. They're going to look at what log does, and if it has the definition, if it's statically linked, it's going to try and inline that definition so that you don't have to pay the cost of a function call because it statically knows it. So optimizations can make things a little tricky, but there's another thing we can do, and that's most of the WebAssembly tooling supports an abstract syntax tree representation of WebAssembly. We were looking at the stack-based representation, but there's another alternative representation that is an abstract syntax tree. Now, it's still going to be evaluated as a stack machine, but it's represented in a way that's more human-friendly. And going back to our 1 + 2, add them together, and then call log, this is stack machine, and this is abstract syntax tree version of it. And you'll notice that at first, it may be a little confusing, but these are called S expressions. And some of you, I'm trying to see if anyone is smiling. No, this looks a lot like Lisp, right? I don't know if any of you have done Lisp, but yeah, it looks like Lisp. And why does it look like Lisp? Because Lisp invented S expressions 60 years ago. So, and S expressions are used primarily because they're dead simple to understand because there's very little syntactic sugar and they're extremely easy to parse. So all the tooling can parse it very easily and compile it. But you can see here that we've changed it. So instead of, I'm going to jump back here, instead of having the stack of instructions, we've instead got an AST. So we can see that we call add with the 2 arguments and then call with the 1 argument, which is the result of the adding. And very often, this is what you'll see a lot of people use when they're writing tests or when you're using all these toolings, just because once you get a function of a decent size, things just get really out of hand. Because sometimes what will happen is you'll have a ton of instructions, and you'll have like one instruction at the very top, like some constant or getting some local variable or something that doesn't get used until like the way bottom of the stack, just because that's how you have to, like, programming in stack machines can get a little confusing and hairy. So you may be thinking, why not source maps, right? Well, source maps are coming soon. They are not currently supported by any browser because there isn't a specification for it, but it is on the to-do list and probably soon-ish. I know there hasn't been a lot of talk about it lately, like there was a lot in 2015 and a little bit in 2016. Lately, they've kind of been prioritizing other things, but source map is coming eventually. So if you compile, let's pie in the sky idea, let's say Elm in a couple years is compiling to WebAssembly. If you set a breakpoint, just like your Babel or TypeScript transpilation, if you set a breakpoint, you'll see your Elm code instead of seeing WebAssembly. So that's the goal. So the next thing is, if this is exciting to you, you might be asking, how do I get started? What do I do? How do I learn more about WebAssembly? If you want to know how the low-level stuff works, like learn more about actual WebAssembly, there's a tool called the WebAssembly Explorer. And this is a hugely underrated tool. Like, very few people have tweeted this, very few people I know use this, but it's so underrated. A guy at Mozilla maintains this, and basically on the left you can type C++ or C, and there's a whole bunch of different versions of that, and then compile that and see the WebAssembly text format and the Firefox x86 assembly, and you can also see LLVMIR. If you don't know what that is, don't worry about it, but if you do, this thing is amazing. You can see exactly in real time what your code is actually going to do in Firefox. Incredible tool, and really invaluable for quickly learning, well, what happens when I do this, and what happens when I do that? And you can find it here. I'm going to post my slides so that you don't have to frantically write this down, or I'll tweet this later, actually. I think I'll tweet this later. if you don't care really about like WebAssembly itself, like you care about using WebAssembly but learning WebAssembly itself, you don't care about that, the first thing you're going to want to do is go to webassembly.org. And why is because they have, it is really early, but they have right now some of the best documentation for getting started with it. What you're going to end up probably using is something called mscriptin, which is a project that's been around for a number of years, but its its goal up until now has been primarily targeted towards compiling C and C++ to JavaScript using ASM.js. And if you don't know what that is, don't worry about it. But it's being adapted because of the tooling is so great. It's being adapted to also suit the WebAssembly purpose. So it actually uses LLVM, and it's basically just another backend to it. And this is how you would compile your C file, your C or C++ to WebAssembly, and you'd get an executable app.html that will load up the WebAssembly, or you can also target just a regular wasm file if you don't want the HTML. So I'm not going to go too much into this because I personally find the tutorial things where like someone's just like showing you basically what the getting started would do kind of boring because you're not all able to do it right now, so you'll probably forget. But the webassembly.org has an excellent just play-by-play of what you need to install. And I'll admit that I'm going to skip ahead just a little bit, one slide. I'll admit that it is a little hairy right now when you're using the mscript and stuff, but Webpack support is coming. They just submitted a grant proposal to the Mozilla Foundation to try and get more funding, to try and hire more people, to incentivize more people to contribute to this so that they can add support for WebAssembly in Webpack. And not just being able to like link different modules together, like calling a WebAssembly module from your JavaScript, but also imagine a C++, a Rust loader, when other languages like when TurboScript and Elm and all these other languages compile to it, imagine these loaders, and so you don't even need to set up all this extra tooling. You can just import it, like you import your less files or your CSS or whatnot. That's the dream and the goal that we're striving to. But we do need more people that are using this. One of the problems we have right now is it's out in Firefox and Chrome, but really there's just not a whole lot of people even playing with it, not a whole lot of people experimenting with it. The companies that are doing it are doing it a lot. Like they're making really big bets on it, especially in the gaming industry. They're making really big bets. But other use cases, we need people to kind of experiment in their free time and try and discover the growing pains and suggest where people who volunteer their time to work on these things should be focusing our efforts. So. And that leads me into what's missing. Where should the specification authors and community members like myself, I'm a community member, not a spec author, but where should we be focusing our efforts? One thing that's missing is direct access to the web APIs. Right now in WebAssembly, you have to call to JavaScript to make any kind of meaningful side effect, actually any side effect at all, really. So if you want to console log, you have to call to JavaScript to do that. It has a great, really easy foreign function calling interface, but you still have to call into JavaScript to that, and that incurs a cost penalty. And it's just not as great because then you need to actually include JavaScript to basically shim those things. But that's not always going to be the case. They definitely plan to provide web APIs to WebAssembly so that you could ship a WebAssembly file without any JavaScript whatsoever, but that's in the works. It's still TBD. This one I've already mentioned, garbage collection. WebAssembly right now is primarily only for manual managed languages. Now, you could ship your own garbage collector, but it would be a little complicated because you can't inspect the actual stack right now. But you could do it, but your garbage collector will probably be rather large, at least a megabyte, probably more. You could probably make like a simple thing that isn't really, it's like a garbage collection, like reference counting or something like Arc from Swift, if you're familiar with that. But garbage collection is really going to be necessary for better interop with JavaScript. So what happens if I call a function from JavaScript and it returns, from WebAssembly I call a function from JavaScript and it returns an HTML node or something like that. There's no way to represent that in WebAssembly right now, because if we gave them an opaque reference to that element, we now don't have a way to keep track of who has a reference to it. I could pass it around inside my WebAssembly and JavaScript would have no idea, so it would have to leak that memory. So interop with garbage collection is going to be super important. Multi-threading. This actually seems like one of the most likely to come next. I'm not going to make that promise, but from my readings and the talks on the tickets, it sounds like this is heavily being designed right now, this multi-threading stuff. And it sounds likely that WebAssembly is going to get really close to native threads, like a very similar threading model to normal C++ style P threads. So for me, that's really exciting because up until that point, like with JavaScript, we only have web workers, and it's really very gimped. Like there's only very, very specific use cases for WebAssembly or for web workers, and having real threads is really going to open up for a lot of things. Now, it's also going to open up for a lot of abuse. So they're still going to do things like preventing you, well, very likely to do things like preventing you from blocking on the main thread. So keep that in mind. And there's a lot more that isn't ideal in WebAssembly for all these other languages, right? For C++ and Rust, it's working fairly well, but all these other possible languages, even things like OCaml, they will be great in the future, but right now they're not ideal for WebAssembly. So the revolution is just beginning with WebAssembly. I think that in 5, max 10 years, that things are going to change very dramatically. And so I appreciate you guys letting me share my passions today, and I hope that some of you will join the discussions, right? Jump on GitHub, WebAssembly/design, check out some of the things that people are talking about. See what it is that might be coming in the problems, and it's also a great place to ask some questions. You know, they're a very friendly crew. People ask dumb questions all the time, and that's totally cool. Like it's totally cool. All the guys are very, very kind and understanding. So when I first got it started, I asked several really, really dumb questions that in hindsight I'm like, oh, I'm embarrassed. But as I got up to speed, it just keeps exciting me more and more. So if you have questions, feel free to find me afterwards or tonight. And I thank you very much for your time.